Well, hey there, everybody. So today we're going to work on Chapter 5, and this is a good time to mention. So if you haven't already looked, now, before you start this chapter, would be a good time to go and watch my video about constraining. So, this is going to be the first chapter that primarily focuses on actually getting fully defined sketches. But if you haven't looked yet, Inventor Constraining 101, watch that video of mine, because it's going to help you more than this book chapter really will. I wish it had more info, but it's kind of vague. It's hard to really quantify some of that information in a book. So we'll go ahead and get started, though, and it's going to have us do a drawing starting on the XY plane. Wait for it. Okay, so here we are on the XY plane, and it has us draw a triangle, and we're inferring here a horizontal constraint as we draw. So, and it doesn't have us choose the origin, so I'm just going to draw it roughly like they have it, making sure I've got this dotted line appearing. So when I draw, it puts that horizontal constraint in, as you briefly saw right there. Okay. So up next, it shows you can hit the Show Constraints button up here. I actually tend to hit it down at the bottom, but that's because you can literally click it and it shows them. Whereas if you notice with this one, I actually have to pick the item, I guess, for it to show. Yeah, so that's not as ideal in my book versus just a master toggle. But the preference is your own. And then it talks about each of these constraints, which if you have watched the video, you will see. I talk about all of these except for smooth, because I have not found a use for it yet. So if anybody does use smooth, I would love to hear how you use it. Feel free to let me know. So next we go ahead and do some dimensions, and it says to use the fixed constraint. This is a terrible practice. I'm going to do it for the sake of this video, but please do not use fixed whenever you're drawing. It's just not good news. But what they're doing is basically choosing a point and saying it doesn't move, which is fine and dandy, but it's not great for design intent, because now like this will move still and this doesn't, but this has no relationship to the origin, which is where your planes are. So don't fix things, but for this exercise, fix things all the same. Okay, so then we have a vertical constraint applied, and I'm guessing a dimension. Let's see. No vertical. Okay, so let's just go and put that in. We'll see where this goes. All right, so then it's kind of showing that when you see these lines, and I've talked about this in the other video, but when you see they're blue, that means there's something left that needs to be messed with. Now, if you grab the line and pull, you're probably not going to get it to move, but if you grab the endpoints, you can see it's flailing. So this immediately tells you, you need either a height here or an angle or something of that sort, because this end doesn't move. So you're basically just missing that one value. In this case, it chose to do an angle. So I'm going to just click. I think that it's just putting whatever's there. Okay, so actually it does say, just to play around, change this to 45 and watch how it dynamically adjusts. So there you go, and that part's pretty cool. This is the power of Inventor. You can edit things, and it, changes things without breaking anything, really. So next, it talks about over-constraining your sketches. And as you're getting started, I'm going to undo that 45, actually. You may notice that you don't exactly know how to constrain yet. So, you may put too many, and you get this notification. So basically what it's saying is you don't need anything else. Like if you're looking, you've got fully constrained like we've talked about, which means anything you add is just bonus points. It's just going to be information it's giving. So you can hit accept if you want to see that value, and it'll place it as a non-editable dialog box, so you can look at it only. It's just for visual representation in case you want to see something. And that's what it's talking about here, that this is a quote-unquote driven dimension, so it's just there for your own viewing sake. So then it kind of goes through deleting constraints. Yeah, so it actually, thank God, it says delete the fixed constraint, so that's a plus. So we're going to turn on this using either the show up here or down here, and I'm just going to click on that lock right click and hit delete. So now, you know, it's kind of hard to tug like on the points when you've got the constraints here. So this is when it's time to turn that back off and then give it a move, you know, see how the whole thing stays together proportionally, it just moves freely, and that's because nothing is tied to the origin point. So let's see how it deals with that. That's a bad way to do it. So there is this command called the auto dimension. You know, I wish it was good, but it's just not. This is something you should really never use. Basically what happens is it just throws in values wherever it can. You know, like look at this. This is terrible. Just some random values, you know, but that's what it does. I have a struggle and problem with a lot of people where they keep trying to use auto dimension, but for the love of God, do not use it. This is a terrible practice, and I wish by default this book didn't cover it, and by default Inventor hid this option. So maybe one day it'll work right, but it's not right now. So what it advises is doing this, and this is actually better. A lot of times in my videos, I do a very basic coincident. You know, I just move the point and snap it here, and that's fine. But I've talked about it's really hard to delete these constraints off to move it. So what the book does here is actually preferred compared to how I do it. I just do it lazily because these videos, you know, they're not meant for master level people yet, you know. So you should do it this way, ideally. Or I'll cover it just since we're here a different way. But it does this. It uses 0, 0 dimensions to locate it. That way, if you ever want to move the part later, you can simply just delete those dimensions. But what I do most of the time, and it's kind of sneaky, but it works. Say I wanted to do this point here, I would do a horizontal constraint, and then for that same point, I'll do a vertical. So you know, you still have that visual aesthetic of it being snapped there. You don't have to worry about two dimensions being there, but it's very easy to go and delete these two constraints. So you know, I feel like that's probably the ideal way, but I'm always open to other ideas. So anyway, then it has us change it to a coincident, like I had a minute ago. So go ahead and slap it back in there, and now we have a random circle. Okay. Arbitrary size, and then it wants to do the auto dimension again, which is just terrible. So then it has to do a tangent, and now it's just showing how when you do a tangent, you know, obviously the item stays perfectly aligned to that line that you chose. So you know, I move it along a path, the size changes, kind of stuff I've already talked about in the other video. But then it shows you can do a coincident to this line. And I think more or less it's just trying to show like what you can do. You know, this kind of feels useless, honestly. So then you could go through and, you know, again, resize it. If you had a dimension on it, it wouldn't resize, but you can see the center stays aligned to this, it stays aligned to that. So all you're pretty much allowed to do is change the actual sizing. So then it has us delete that constraint again. Basically just playing in the sandbox right now. And then same deal. I'm going to do coincident to the line. And now, if I turn my constraint visibility back off, you can see it's the same principle. It stays center aligned to this bottom line. It slides upon that slope, which is cool. But, you know, you're probably not going to do a lot of that. So now we have, I'm going to undo a few times here, save myself having to delete all these constraints. So now we have an actual shape here. So we're going to bump this to 35, make this 3. I'm going to just move this kind of where it should be and scale it a little bit. So then we have 0.75, 0.75, and 0.75. So then we're going to extrude it 0.25. You know, I always preach about it. Make sure it's symmetric. In that same video I made, I talked about invert constraints. It's kind of a long spiel, so I would say, you know, make sure to check that out if you haven't. So now we're just going to throw away everything we did, you know, like that was part one, I guess you could say. So now I'm going to do another sketch on the XY plane. And let's see. We're going to do a 2-point rectangle. So let's go ahead and slap that in. And for whatever reason, oh, okay, I was about to say I didn't see my origin point, but it popped in. So we're going to do that, and then we're going to put a center point in, center point circle. So I'll just slap it out here in a quadrant. So then we're going to have these values set up. Alright, so everything's scaled. Now we're given a value locating this top portion of the profile, and it's going to be 1.5. Do the same thing over here. And it looks like our circle is actually going to be coincident to that center point. Okay, so now it just wants us to play with values again. So we'll change the width to 6. It's going to become a little asymmetric. The height to 3.6. And again, now we have asymmetry in this direction. So you know, it's just showing basically like if you're sizing something and locating it, you know, it's going to stay proportionally located the same direction. So the only way this is going to adjust here is if you use an equation here, you know, saying that that is half of that. That would be the way that it would stay tied to that center location. But it actually wants us to proceed with the 3 and 5 values, so I'm going to undo that. Okay, so this is a fun time to talk about naming of equation items, I think. Let's see. So first of all, it mentions, take note, whenever I edit this value, it has a name. D0 is the name, you know, so this is D1, D3, and so on, you know. So basically what it's saying is, you know, these values exist in a master place, so it's good to know that these names exist. So we're going to edit this dimension, and we're getting fancy now. So this is exactly what I talked about. I'm going to take D3 and say that it equals D0 by clicking it, and then type in divided by 2. So now this one will be tied to that one proportionally whenever I edit the top one. So then we're going to do probably the same thing with the rest. Yeah, okay, so this one equals this one divided by 2. Okay, so now it's going to talk about what that means, but I like to show it. So, you know, if I change this to 5, bam, that one changed 2. And if I change this to 2, bam. You know, so that's pretty cool. But if you were to go to the Manage tab and click on Parameters, or my preferred way, I would say immediately always do this. Click that Quick Access Toolbar drop-down and turn on Parameters and Measure for your parts, because it's going to be very convenient just to be able to click this button up here. So I'm going to click it up here. It's the same difference whichever way you go. And you can see this is a lot of information, but looking here at the parameter name column, the consumed by, and then equation, you can kind of tell we've got the same values from earlier. You know, you've got D0, which was that width, and it shows it, and then you've got D3, and it shows, you know, that it's divided by 2 of D0. So you still have all this information in one master place. You just probably didn't know it existed. You don't have to look at it in a sketch. You can actually edit it all right here. And, you know, basically what you have is the names, which you can actually go and rename, you know, so it's easier for your own sake. And then you actually have what these are used in case you forget and you have a lot of sketches. You can actually see where these parameters are located. And that's what each one of these is a different parameter. And then you have like a different way of showing the value, and you probably won't use most of this over here for a long time, but comments are great, you know, because you can give yourself notes about what's what. You'll grow into all this over time, though, and then eventually you'll probably get into units where not everything is inches. You know, you may have, you know, one other form. There's quite a few. I tend to mostly just use UL besides inches, but there's different things, and you'll get into it. So anyway, now we've taken a little pit stop over there. We're changing those values that we had earlier. So I'm going to do it in the parameters, though, just to show you guys the difference. So when I change this width, it's 6, and when I change this height, it's 3.6. So now when I hit done, bam, they've already updated. So that's pretty cool. You know, technically it wanted you to double click and edit, but you've been doing that, so you understand that concept already. So then we're going to extrude it 0.25. And hit save. I really thought we might have you know, covered the parameter. Well, I want to cover one more thing in parameters that it didn't. Okay, so if you do want to change the value, you know, to a different name, you can just call it width. You know, the only thing you can't do is like type in words and then have a space. Parameters do not allow spaces, but I can easily go in here and type in height. Or say I'm not very comfortable with parameters yet, and I'm not used to that format, and I don't feel right using it. I can actually go in here and do it on a dimension. So you see I've got D4 for the name for the circle. I can hit home, or you know, navigate to the front before the dimension, and I can type in OD or whatever, you know, I want it to be, and then type in equal. So what's going to happen when I hit enter is it's going to take that equal sign and use that information to say everything to the left of the equal will be the new name for the part, and then the value to the right of the equal will be the actual value. So when I hit enter, the value stays at 1, and now when I edit it, the name is OD, which you can also see in the parameters now, of course. So that's a good little, you know, need to know item as you're trying to get more sophisticated with your drawing. You know, it helps to be tidy, and naming your parameters is going to be crucial one day, so it's good to kind of know that you can. So now we're going to play with the measure tool, and you know, it's pretty great. Same deal, like I said earlier, if you haven't put it on your pen quick access toolbar, definitely do so, and you may have to expand this to see everything, but it has us change our precision to 4 decimal places. So I'm going to click 4, and then we're getting a slant value. So we're going to choose point to point, and there's what we get, 6.9971, blah, 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 blah. So see, here's one thing that people don't realize. There's always a round off when something's not perfect. So if I were to change it to all decimals, you would see there's actually more information than we're given. So sometimes it may make sense to measure at a different precision. So this is a pretty useful tool. So then, well, you know, at this point they're just getting silly, you know, changing it to wireframe and all that. They're just showing off things you can do. But you know, if you do want to play around with that, I tend to like shaded with edges, but you can see, you know, like hidden edges and stuff. I guess if you had, you know, the model in the right place, you could see that. They chose wireframe. I just don't like that. What's the point of doing 3D if you can't see anything, you know? So, yeah, so you can restart the measuring tool. To me, it's just quicker to, you know, click this, measure whatever, and then just hit, you know, the measuring tool again to restart it. Like, that's the fastest in my opinion, which is why I advise it being up here. And then, you know, with circles, it's kind of finicky. You got to be careful to read the right information. It gives you both values, as well as, you know, so say I go and measure to like the center point here. Sometimes you may have a minimum distance that doesn't match. I didn't do it right in this case, but sometimes you really got to be cautious to make sure you're reading the delta option instead, you know, because technically this distance to here may not be the same as the delta distance, which is you're going to be your XYZ in relation to your gizmo. So yeah, so that's going to be it for this one, it looks like. So this first one's in metric. So we'll open up a standard metric part. And let's draw on the top view. You notice it rotated my view cube here. Seems to be consistent about that. Alright, so it's a radius of 30. So we'll do a diameter of 60. I'm going to ignore drawing the other ones. Well, no, I say that, but I'm going to go ahead and just draw the whole profile. Alright. Draw some horizontal lines. I'm just going to draw for now like a little staggered spot where we'll put the marks at. Draw the same thing on the other side. Okay. Let's make this tangent. Drag this back up. Draw a circle at the midpoint. And notice it snaps to that midpoint when it turns green. And we'll just connect it to the other end. Guess that was a bad move, really. That's okay. Make that tangent. Extend this line. Trim, trim, trim. You notice I only see one point here. I'm not sure if that one's there. Let's see. Yeah, okay. Need another circle in here. Let's go ahead and start doing some dimensions. I shrink a lot, apparently. Thanks. Okay. Let's say that this line is collinear to this line. Then we need to make sure to put that all of these center points are horizontally aligned. This is 30, 20, 10. This hole equals this hole. And this is 20 as well. Okay. So, maybe wondering about these little fillets here. I could technically, go ahead and finish, and I could do the fillets in the next feature, which I am going to do, but I'll show you an alternative option. You could also make the circle tangent here and here, and then coincident here and here, and then trim. That would be fine. Alright, so it's 10 thick. We're going to go down so we can reuse the sketch for the other part. I'm going to turn that sketch visibility on, or I could hit share so that I can extrude this way. 5. Okay. Turn that sketch visibility back off. And then 15 fillets. Yeah, works good. Okay. So that's the swivel base. Next we'll do the anchor base, which is going to be in inches. So we'll make sure to open up a standard IPT. And we'll draw this one on a front plane. I'm just going to go ahead and just draw, as is customary, the rough shape of this part.
And I may be pretty off on the scale, but that's okay. Let's see, so it should actually be down here, kind of. And as you can see, it did mess up and not stick at a perpendicular or vertical alignment. So I'm going to go ahead and fix my goof. And I'll make sure to snap where this one does and where this one does. Okay, so let's slap in this overall width so it controls everything, because it's going to grow 3 times the size. I'm going to go ahead and slap in overall height if I know it. No, but we know it's 2 to the top of this. And this is 0.5 tall. And we'll just move this back in place. No problem. So we'll say that this line is collinear to this line, and it already knows that apparently. So that's good. So we'll say this one is equal to this one. This is equal to this. This is equal to this. This is equal to this. And I don't think it'll let me. Let me double check. Yeah, okay, cool. So I can still say that this one equals this one. Nice, okay. Good stuff. 1.25 between these two. I'm going to locate this drawing horizontally, saying it's centered. From here to here is half of this. And then I'm actually just going to say that this line touches this point. That way, you know, it looks like it would be some kind of, you know, mounting pattern, so having a plane at the bottom might help. It's 0.75 tall. .75 wide. And 1 between here. 0.5 here as well. Okay, so there's a rough sketch, which is some amount of thickness. It's a PlayStation 5 reveal event earlier. Can't blame everybody for being excited. Okay, so I'm immediately led to believe that this 0.625 times 2 equals the width, but I'm trying to see if I see an actual width here. And I don't. So let's just see what that would look like if we extruded it. 0.625 times 2. And that's got to be it. Okay, so we'll do chamfers to start since they're pretty low-hanging fruit. And it says 0.3 equals, so we can just do a generic 0.3 chamfer. Okay. We can go ahead and do a circle and another circle. I believe they share the same center, and they do. So 1.5 to the center. And we'll say that the center of this top edge is aligned to the center point. So now all we need is a size. We'll change this one to a radius because we're going to trim it. It does not share the same center point. Okay. Let's draw it out here. You know it's vertically aligned to this point. So now let's just say that it's coincident to this corner. Actually, it's tangent. I apologize. Okay. So we'll trim that. There's nothing to trim. Project these edges. Now trim. And then we should just be able to go ahead and extrude since we had that projected edge come in to fill out the rest of the profile. We're just going to do through all both ways since it's easy. And we'll do some holes on this top plane. Alright, so let's lock them horizontally to each other. Let's say that they equal each other. Let's dimension it. Alright, and I'm dimensioning these like this without doing the edge projection to save from having to do it. If you notice, before I click this edge with a dimension, it doesn't turn yellow, but once I do that, it does become yellow. It doesn't seem like much, but it is saving, you know, a few seconds, which can be very convenient. You're doing this over and over again. Alright, so we'll do the same thing to the other side, and we'll go ahead and extrude it. Okay, there is the anchor base to the wedge block. It is also inches. And looking at this one, we'll do a front view or front plane for this one. And I'm just going to go ahead and draw this one from the point from the beginning. It's about 6 wide. It's got a little slope. And it plateaus off. It's kind of hard to read. Okay, so 6 and 4. Oh, we don't need that 4 for now. We do need a circle. 1 tall on this bottom end of the slant. 2.75 tall overall. 1.25 for this hole. Okay, so there's our sketch. And we'll make sure to extrude it both ways. Oh, I almost goofed. I was going to, on the next step, go ahead and extrude both sides, but as you see, it's flat on this other side. Good to know. Alright, I'm just going to draw a triangle, and then I'll constrain it in place. Sometimes when you go and try to draw it in place, it'll end up pulling up all these random constraints, trying to think of what you want, and it's usually not right. And it's just easier to draw it out in space. But as you see, I missed a click earlier when I was doing it, apparently. So I just need to go ahead and say it ends there. And inconveniently, they gave us the long dimension. Alright, so we'll extrude cut both ways. And now we'll do the back view. We'll make the center point of this align to the center point of the top edge. And extrude cut both ways through wall. I guess that's it. That one seems a little easy after doing the last one. Alright, the hinge guide. So this one, we could do the same approach with the fillets, but this time I'm probably not going to draw them in the sketch. I feel like this one's a little easier to just add the fillets later, but it's in inches. We'll draw it on the front view. It's about 2. So this one I'm going to kind of just draw the rough shape, and then I'll just trim and put whatever else I need in after. Let's see. Yes, we don't need that. Cool. And then we need a slot. Okay. So R1, 0.5. And if you know, I trimmed these. I may have not even cut that originally myself, but you know, this arc becomes independent. Even though it came from this one, the geometry is now separate because you trimmed it. So I need to actually say that they equal each other. And then let's locate. So the slot currently moves together, but it slides freely. So we need to locate it in reference to this point of the circle. Just say, you know, from here to here, it's half. You could also do the same from here to here, of course. Okay, let's pull this up a little bit. Do the same thing on this side. Say it's half of there. And then it's 4 wide. Too deep. And we'll add the fillets here this time around. R3. Alright, we need some holes. Something like that. Yeah, okay. I know that these flailed, but I'm just going to go ahead and add these dimensions in. Here's a neat trick. So, say I want this feature to be, or this point to be aligned to the center, but I don't have an easy reference point. Like technically what I've been doing is I align a center point, but for whatever reason, if you don't want to do that, you can always dimension here, place a reference dimension and say it's half of that. If you notice I hit accept earlier, that's one way, but I am still going to use that horizontal constraint. And then this guy, it keeps the same uniform distance, but it kind of spins around in a circle. So basically I need to align these points vertically. Now let's do a hole command. Say that, you know, all but this guy are 0.25 straight through, no seat. Turn the sketch visibility on. So the next thing we would do is add in that extra hole, which is going to be a diameter of 1 with a seat, a counterbore. Oh, that might be exactly what we need. Only difference is 0.5 here. There we go. Yeah. And sketch visibility back off so we don't have to see that ugly thing. And there's the hinge guide. Now what's unfortunate, I can tell already by looking, if you look at this cap, it's smaller than the one in the book. I think that the book probably should have been half of that, 0.125. Yeah, but that's okay. So, you know, hold what the dimensions say. And let's move on to the next one.
So first things first, we'll start off with a sketch on the front plane. And we'll do a 2-point center since we're going to have a square. And it's going to be a 4x4, so we can go ahead and dimension that. And I'm just going to set it to equal the other dimension. Okay, so then it's going to be extruded 1 deep. And you know what? I'm actually going to go back and draw that circle in. Might as well put it in while we're here. And it's going to be a diameter of 3, and it is centered to the square. So now I'll go ahead and extrude it 1 deep. And then we've got our little circles here. So all that we're given is it's 0.75 extrusion, and then you're kind of left to assume that the center is aligned to the center of this part. So I'm just going to go ahead and draw the profile. And this is actually going to be the center of the part, so this kind of works out pretty well. Then I'm just going to go ahead and project some edges. And I was hoping we might would get more info here, but it didn't quite grab it all. If you saw, it kind of implied there was a tangent, but it didn't snap to it, so that's okay. So then we're going to have another circle, but you know what? Actually, no. I'm just going to do I'm going to extrude this portion, and then we will do a hole command for the other part because it's going to take 2 features anyways, since we need the hole to go throughout. So we'll go ahead and just do this part, and it's going to be 0.75, I believe. Yep. All right, we're going to do the same thing over here. Again, conveniently, we've got the center of our circle projected here, so you know I don't have to worry about aligning it or anything. And that time it did take our tangent projection, so then I'm going to project the rest of the edges so we can not have to draw them. Trim out and extrude this one. I'm assuming 0.75 as well, but let's just take a look. Yeah, it doesn't say, so it's assumed. So then our last step will be to put these holes in. So I'm going to choose the face and the edge, and then our hole size is 0.5 for both. So I'm going to do a flat bottom, and then I'm going to do, well, I was hoping for a 2 next here, but let's see. There we go. Sometimes it's finicky about that. You know, you may have that problem where it won't give you the option to change that. So I chose 2. I chose this face. And now I'm going to do the same thing up here. I'm going to choose this and this. And then choose through all to reset it, I guess. And then choose this. So yeah, that one's pretty straightforward. It's going to be it for this one.
Okay, the support fixture. Just gonna get all willy-nilly and start drawing this one. Okay, so can't tell I'm drawing that back face first. Make the circle tangent to this circle, or to this line. Same for the other side. Let's say that these are parallel. They're already parallel. Let's make this one horizontal. Trim. Just make sure. Okay, make sure your circles are also horizontally aligned. Yeah, that's better. Okay. We got 7. It's way too small. 1.5. 1.5. Go ahead and locate this. We want it to be half of that. And I'm just going to say that this circle is horizontally aligned to that point. It's going to be 1 thick. Extrude away from that sketch, that way we can draw on the plane a little more conveniently. There's different ways to go about this. I'm just going to draw the rectangle and then I'll add the rest. There's not like a great way to draw this little profile. It's going to be 1 thick throughout, it looks like. So this is 0.5 for the inside bend, 1.5 for the outside bend. Okay, and it's 2.25 here, and 5 to a very inconvenient center dimension. All right, so extrude both ways. 4. We're going to cut this part out. Share the sketch by turning on the visibility and extruding. We're going to choose join here. And it's too deep. Make sure to turn the sketch visibility off. Oh, you know what, guys? I moved. I don't know if anybody noticed that. It's 2.25 is to the other face. Here we go. Sorry about that. That's going to be